Hey everybody, this is Aaron Murakami with eMediaPress.com and the Energy Science and Technology Conference. Today is September, the 28th, and we're here at the shop here in Spokane, Washington. This is where we manufacture the MWOs and do a lot of the projects with Eric Dollard, and Jeremiah from iEnergySupply.com is up here this weekend. Jeff is helping him with the little project for the next Tesla turbine you're building. So
yeah, we're building another 3-inch and a 4-inch Tesla turbine.
So what are some more of the details? This one is going to be carbon fiber, and what are your goals with this next one?
Well, our latest turbines have all been carbon fiber, and we have a 64th inch gap between each disc, which is really important. But we want 2 different sizes to test. We're about to get a bunch of analytical equipment that will show the like the volts and the amps on the output of the generator, plus the RPM of the turbine, plus the temperature in, the temperature out. We're going to get a mass flow sensor to watch what happens with our flow, and all this information is going to be
So you're actually going to see the volume of airflow? Okay.
You're going to see volume as well. We won't see that right away because we're waiting for that sensor to arrive, but we're going to start with the other things, like the temperatures in and out are going to be really interesting, and we'll be able to see the how the speed relates to the temperature in and temperature out, the efficiency, how many watts we're getting out at what speed. So we'll start with just running the turbine up to speed, and then looking at the temperature differential between the exhaust and the input, and then we'll add a little load at a time at certain speed increments, and we'll see how much of a load we can draw before the efficiency starts to drop for a given size turbine. And we will have Nikola Tesla said that the turbine performance augments with size, and he also said that with smaller turbines you would need to stage them because there's less surface area. So the inlet of one turbine would go to the output of one turbine would go to the inlet of the next turbine, and that's staging them or compounding them. But he also said there's 2 factors that decide whether you need more surface area, and that's the speed of or that decide the power. That's the speed of the turbine and the amount of surface area you have. So he said with higher speeds you won't need as much surface area. But like I said, he said it augments with size by an exceedingly high rate, so the surface area goes up exponentially with larger turbines.
Same in the electrical systems too, like with voltage and the reactive power generator, like what Mike Clark and Paul Babcock's working on. At 12 volts the results are there, but it goes up exponentially as you're going up 60 volts, 72 volts, and
it's interesting. Tesla said that the turbine's more practical with larger sizes, unless you compound them, which makes it a little more complicated. So we might be able to make up for that with the speed without building a larger turbine, because carbon fiber is just way beyond anything that Tesla had in its time. And Tesla was able to achieve some pretty amazing results with what materials he did have, and that's contrary to what the public knows. Everywhere you look online, they're going to say, oh, it was a failure, but Tesla, when they said it was a failure, Tesla had been working on the turbine for 10 or 15 years after that, and made all kinds of innovations on the turbine, and nobody hears about that. But like I was saying, the point I was trying to get at is the mechanical oscillator, which is a project we're going to be working on soon as well. He said that works very well with smaller size systems. So if you're just doing a real small off-grid house or system for the off-grid for a house, or for a small house or like a trailer or something, smaller unit, or if you don't need as much power, you can use the mechanical oscillator, and he said it works surprisingly well. Like it's better for smaller units.
Okay.
And the turbine's better for larger units.
So if you're watching this and you're not too familiar with Jeremiah's work, he's kind of heading up some of the best research in the world on the Tesla turbine technology, which his website is ienergysupply.com. He's got a Facebook page, a YouTube channel with a bunch of videos. He also has a Patreon page where if you want to donate on a monthly basis to help support him, there's different tiers with different benefits in that. We're working on putting up a new draft website. It's still under construction. More content's going to be put on there, new blog posts, and that's ienergysupply.com, which is the domain name that you've already had. Website hasn't been too active, but that's where Jeremiah will be putting a lot of his posts, and so like in Facebook and wherever, there'll be links going to there, so you'll be able to get updates, and then there will be a mailing list you can join, which will be kind of his main one, because there's Patreon, Facebook.
And we've never really had that before, so.
Yeah, so that'll be coming up. I'll put the links as subtitles on this video. And then in July, God, this is already almost October, so beginning in July is the Energy Science Technology Conference that I host up here in the Inland Northwest every year. And this was the 10th annual one, and it was at the Kootenai County Fairgrounds in Coeur d'Alene, Idaho, which is right on the other side of the border from Spokane, Washington. And it was an amazing success. We had a lot of demonstrations. We had about 17 presenters, maybe about 20 different presentations over 5 days. Jeremiah's gave a really exciting presentation, because this year he was able to show the cryo system,
the demonstration
to the public, and it was a success, and it worked.
Yep.
And so you'll be able to find that on emediapress.com, or if you're going to Jeremiah's page, you'll be able to find that on the recommended links page. And another thing on Jeremiah's website that's under construction right now is that there will be a like a shop, basically kind of like what we have at emediapress.com, where there'll be a couple products that he's recommending that will have external links going elsewhere, but they're also setting up their own ability to sell their own products. And are you comfortable in saying that at least some type of Tesla turbine in a kit form is going to be coming relatively soon?
And basically all we're waiting for, and all we're waiting for is we want to get some testing out to show everybody, some real numbers and give people real figures, other than just demonstrating the system functioning, which is what we've done so far. And we also want to size the turbine properly so that people can get so we know exactly, or we know how much power they can get with a certain size turbine, at what temperature and what speed. But I know there's a lot of people out there who want to experiment with the turbine as we go as well, and so we will have turbines. We want to have turbines very soon listed on our website.
So the yesterday Jeff was working on fitting a shaft to the bearings for this new model that you're building, and is that going to be the one that you'd consider the production ready prototype once you get the data out of the way, that it'll be based on that particular model, or do you have another one in mind, or it will be that one?
It's going to be a 3 or a 4 inch. We're going to test the 3 and the 4 inch turbine and decide which one we want to sell.
Okay.
And also, for a really small system, we might just sell the 3 inch turbine. Now, if we can get stable runtime at 150,000 RPM, which is what we were able to achieve, it wasn't stable because we had to upgrade the thrusters that thrust the bearings to the inner race of the bearing to the outer race of the bearing. We were using rubber, and at those speeds, it stretches the rubber. It doesn't hold itself together. So we will be using metal thrust washers, and if we can maintain 150,000 RPM, there's no telling what kind of power figures we can get at those speeds with extremely low temperatures and pressures.
Right.
And so all the exciting stuff is coming really, really soon. We've already got the turbine, the 3 inch turbine prototype there. It's built. We just got the magnets put on the shaft for the generators. It's going to be a dual generator, and Right now, if you want to, right now on our Patreon, we have all the plans and stuff to build it, and I just made videos showing how to construct it. We have the CAD drawings on our Patreon as well, and so if you want to build one yourself, you can go get those plans from our Patreon, and then we'll make that available in other ways in the future as well. So yeah.
Okay. So now, as far as 1 year from now, let's say we have the 11th annual Energy Science Technology Conference in Coeur d'Alene or Hayden or wherever, and what do you see where your accomplishments at that time?
I want to have a 3 kilowatt turbine running at the conference with the boiler and the condenser, and have a recycling. I want to recycle the condensed water back to the boiler, and then have it all just functioning with some solar heat tubes, which we do have. I want to have all that set up so that it's the complete unit, the complete system, all sitting down there, just running and running and running from power from the sun. So
3 kilowatts. How many of the evacuated tubes do you think you might need for something like that?
I think it's around 30 evacuated tubes for a 3 kilowatt unit. And of course, your battery can be any size you want. We would like to have just, how people have those, if you've got a well or something and you get a big tank of water to store water with. My dad's got like a 1,500 gallon tank that would be perfect for what I want. Insulate the outside of that, and you have a giant battery. Even if our efficiency numbers weren't 99% or what, some crazy number like that, even if it was just 20%, we would outdo all the solar systems out there. So yeah, because you can store so much energy, and the crazy thing about storing energy in water as a battery is you don't have to worry about how fast you charge your battery. Normally you have to spread your charge time. It depends. If you're using lead acid batteries, you have to have a good 8 hours of sunlight to fully charge your batteries. The last 20% of that charge takes the longest amount of time. And with water, it doesn't matter how fast you put the energy in. If the sun's out for 2 hours and you have enough solar, you can pump an insane amount of energy into that and store it into that water without having any issues. And even lithium ion will have issues with trying to charge too fast. And you can also have a big windmill that if there was a windstorm, you could capture that windstorm as well, because there's no speed. It's basically like having supercapacitors, because the energy can get dumped in as fast as you want. But also the amount of energy that you can store for the same price is ridiculous, because we calculated one big lead acid deep cycle battery is about equivalent to a gallon of water, from I think 60 degrees to 212 degrees. To boiling, it's almost one lead acid battery. But if you get a 1,500 gallon water tank, that's almost like 1,500 deep cycle batteries. This is just rough calculations. And we need to find out what our efficiencies are and stuff. But even with low efficiencies, you've got a battery that can cost next to nothing. Like $700 and something for the tank. Then you insulate the tank, and it lasts forever.
Okay, so just to emphasize the point between the heat and the regular solar systems is that regular solar panel 17%, 20% if you're lucky.
Yeah, some of them are like 12%.
Yeah,
I know an old one's going to be even less, but
yeah, it's worse than an internal combustion engine.
And then you charge your battery, and then you lose a little bit of energy charging your battery, and then when you discharge your battery, you lose a little bit more energy on top of that.
So like if this is a solar panel, out of all the sunlight hitting it, it's magical if you can even get 20% in electricity out of that, because the efficiency is so poor. But if you take the same amount of sunshine and you create heat, hot water, glycol dumping the heat to water, then those evacuated solar tubes, those are like 95 to 98% 100% efficient.
Yeah, as long as you have good insulation on everything, then it's extremely efficient.
So it's already like, you know, over 4.5 times more efficient than sunshine to electricity. Is you can get close to 100% by going sunshine to hot water, and then if you have the hot water and you use the Tesla turbine method to then take that hot water and turn a generator, turn it into electricity, even if it's only doing it at 50% efficient, you're already 2.5 times,
and not only that, but
over solar electric.
But not only that, but you're starting with 16% with the solar panel. You charge your battery, you lose another, like say 10% of your, or maybe more in some cases. You lose another 10%, so you say 16, and then you minus 10% off of 16%, and then you end up with like 11 or whatever, you know, percent. And then when you discharge your batteries, you take off another percentage. So ultimately, it's going to be a piece of cake to get this thing to be way better than regular solar system.
Yeah, sunshine, hot water, Tesla turbine, generating electricity. That's the only way that makes sense as far as solar electric goes. And I see some of the comments in the YouTube videos, like mine or yours or whatever, and people are like, okay, well, what is it doing under load? Well, obviously, it runs under a load because you're lighting, you know, bulbs. You've lit over 1,000 watts worth of bulbs. And so
I was using quite a bit more pressure, but with 1,000 watts. But that was with compressed air in atmospheric pressure. Once you take away the atmospheric pressure and you put it in a cold steam environment, the atmospheric pressure, what it does is it goes up inside the Tesla turbine and it clogs it up. And so when I ran this thing on air, it takes 60 psi to get, say, it takes about 45 plus psi to get the turbine up to 66,000 RPM, whereas with the cold steam system, it only takes like 1 psi to get it up to 60,000 RPM. So compressed air is you can't compare the two, because when you remove all that atmospheric pressure, everything changes. There's no more stress. There's no more virtually all the back pressure in the exhaust of the turbine is eliminated, and that makes the turbine basically. If you think the best way to think about it is, if you take a vacuum chamber and you put like a spinning top in it, it will spin 20 times longer, right? Same, and because there's no friction on the rotor to begin with. And so with the cold steam system, we remove all that. So the turbine's basically sitting in pure vacuum before we even turn on or very high vacuum before we even turn on the turbine. And so, yes, we needed like 40 or we needed a higher PSI to get 1,000 watts with compressed air, but we're not going to need anywhere near that much with the cold steam system. And we've only been testing very, very low temperatures with the cold steam so far. So we're going to kick it up to a maximum of 212 degrees Fahrenheit, because we want to stay below atmospheric pressure. And once you reach 212 degrees Fahrenheit or 100 Celsius, then you start to build up pressure in your boiler. But we won't allow our boiler to actually build up any pressure, because we'll have a simple flap on a hole, a rubber flap, that when you put it under vacuum, it sucks that flap down and plugs it up to keep atmospheric pressure out. But if it even gains 0.001 psi inside your tank, it'll just vent off the steam. So there's absolutely no way that it could possibly be dangerous. Even if your tank rusted through and it collapsed under an implosion, it would implode instead of explode and end up harming somebody. So it's completely safe.
So talking about, you know, water tanks. So like you know, Eric Dollard has his lab down in West Central Nevada. It's a few hours north of northwest of Las Vegas, and in the ground right outside the shop are two 40,000 gallon tanks. So he's been watching your videos. Of course, you know, he knows what you're up to, and he was impressed. He was impressed by your demonstration at the conference, and you know, he's in the mode of electrostatic generator, because that's basically the Donald G. or a John G. Trump. He has a patent on an electrostatic generator, and if you look at these rotating electrostatic converters like the Chris Carson one, in the patents they don't really say it, but the output is not directly proportional to what's going into it, and so they're kind of making a free energy claim, an excess net gain But that's something that he kind of wants to move in a direction of developing that at some point. Okay, now the other thing is, do you want to work with him on developing a Tesla turbine to use those 40,000 gallon tanks?
Yeah,
to
of course. That'd be great. The only thing I'm concerned about is insulating them.
Yeah, so it's just in the ground. I don't know if it's bare earth or what. I haven't seen them. You know, Eric knows the details about them, but there's 2 of them. They're 40,000 gallons, so I'm, assuming this water's sitting at about 50 degrees Fahrenheit. And so if there was an array of, evacuated solar tubes, say 50 of them on top of the building, just constantly pumping
all summer long, right?
Just all summer long down there in Nevada.
And then you could heat your building on it in the wintertime.
Sure.
And also, if you did insulate those tanks,
yeah.
In the wintertime when the sun's gone constantly,
sure,
you'd have such an enormous amount of energy stored in
that's a massive flywheel. I mean, that's 80,000 gallons of water.
Yeah. You'd be able to basically run all wintertime on the same battery.
Right, and that's what he wants to do, is use the hot water in there to heat the building. But also with the the 2-stage cryophorus method, generate electricity at the same time.
Yeah.
So and Eric is serious about this. He wants to move forward on this and see that happen. And the electrostatic generator part that he wants to develop is a whole other project. But just the cryophorus system, it's.
I'm always down to test stuff.
So we definitely.
And we can make it spin as fast as he wants it to. So.
Right. Yeah. So he wants to, probably a good time to at least get the conversation going, to just, get that going, so he can, give you whatever details, and you just kind of think about it in the back of your mind and that kind of thing. But that'd be an awesome collaboration to have, Eric work with you on the Tesla turbine system to actually run the lab.
Yeah, that'd be cool.
Heat the lab that method and generate the electricity. So now, with a possible Tesla turbine kit coming up, that'll be available through your website. What's the time frame for the to get this next production ready prototype built? What is the timeline to do all the testing till you think you're going to be satisfied that you have all the data? And then what is the time that it's going to take to source the machining work and everything, to have a shop that's going to be able to kick these out in numbers? Maybe like one month each or something, or?
I would say, total for all of that to happen.
Yeah. So what's the time frame to build the next model?
It would probably be for the next model, the 4-inch model should be done in a couple weeks. The 3-inch model should be in about a week. The 3-inch model should be being tested, and then in a couple weeks, the 4-inch model we will be testing that. We do need to get a bunch of plumbing fittings so that we can hook all this up. We've got 95% of what we need. We need to get more carbon fiber for the 4-inch turbine, with just the 64th-inch discs, and then we have all the rest of the materials. We should get another set of bearings. See, what I want to have is I want to have my exact same design that I know can get ridiculous RPMs, and the RPMs problem is solved, and then I want to take and have at least 3 sizes. So the 3, the 4, and say like a 6-inch, and then I would like to test all of them. And like I said, Tesla said that it augments with size, so it gets much easier, and we've already got the RPM issue solved. So because we can run on extremely low temperatures and extremely low pressures, we want to see how which size we need to make our 3 kilowatts practical. Because it might be that our 3-inch turbine can only get a kilowatt, and we would like 3. So.
Right. So
we need to see the difference, because the surface area is going to go up exponentially with just a slightly larger diameter.
Okay, so we're about to hit October, and so it sounds like possibly about 6 weeks. Both are built, and there's been enough testing. Probably by maybe the middle of November, you think?
Yeah, that sounds about right.
And then what, maybe roughly a month to
December and November.
Source all the work getting done and to actually, put these into production to make them available?
November, I might be in Chile for a month. So I'll be working on interpreting data and making animations and writing information down, and probably editing videos and all that stuff. But that would give me it's like 4 months away, so I should be able to get all the stuff I need done before then. But then I'll be back at it after that. Yeah.
Okay.
And then there's a possibility I might not even go.
Yeah.
It just depends on how things go. And if I'm not ready to go, then I won't.
Yeah.
If I'm not ready for, if I'm too far behind, then I'll just stay.
Right.
But I'd really like to go. So.
So possibly early January might be a time where these might be able to be pre-ordered with maybe 6-8 week lead time or something like that. That might be realistic.
Oh, for pre-orders, we could probably pre-order a lot sooner than that.
Well, as soon as you have it worked out where the parts are going to be kicked out in numbers, and
yeah, I would say.
But we're going to put the updates on Jeremiah's page, and I'll be sending out updates on my newsletter and blog and whatever. And but this is an important product to get into people's hands. It'll be something that you're going to build yourself. Obviously all the information is going to be there on what these things have already proven to do.
Yeah, so I would say let's put some updates out, because I got to think about all of that. Now that I got those shafts done, I don't have to worry about that. Our testing equipment should be here in 4 or 5 days, and so yeah, I think I just in a couple of weeks I could answer all those questions.
Now, is there
more accurately?
Is there a and you recently put out a new video? What is the title of it? That's
basically the summary of our entire
kind of taken off.
Yeah.
Okay, so it's
summary
your story,
of everything
basically.
that we've been working towards. Yeah.
Okay.
And we showed the whole system all there, like in a small condensed version that you can see on camera, and it's their intro to our YouTube channel at the moment.
Okay.
So that's we've done so many different videos, and there's information spread throughout all the videos, and we kind of just did a summary so that people know what's going on. It's a lot easier for people to understand.
Right.
And it was edited really well by a friend of ours.
Okay.
So.
Okay. And make sure to get a copy of Jeremiah's presentation from the 2020, or actually 2021, Energy Science Technology Conference. It's called the Tesla's Thermodynamic Transformer. Last year you did that presentation by that same title, and that video was never released because we're hoping that we're going to be able to get at least the demonstration on video.
Yeah.
And so that wasn't able to happen, so I just kind of held that video, but that's we're making that available because there's a lot of good information in there. Some of the information is the same in the new one, but they're different enough to where they complement each other.
Yeah.
You get more of the full picture if you get the 2020 presentation and the 2021.
And I did learn a lot since then.
In the last year, yeah, the whole year.
I mean, there might be stuff in there that I would say, well, maybe that wasn't so accurate.
Yeah.
But for the most part, it's the goals have been the same, and we've been achieving the same, or headed in the same exact direction that we wanted to go in before we got the working prototype done at the 2021 conference.
Okay. Now, are there any like tools or parts or resources or anything that you're looking for right now? Or are you pretty much set with what you need?
We could use a good lathe. We got one of those $700 Harbor Freight lathes, which helps. But
what size do you need? Something like what's in here?
Yeah, like what's in there. I mean, that would be perfect.
Do you know what size that is?
I don't know.
Here, let's take the camera in there real quick and. So this is the equipment that was originally John Bedini's. Peter had one of these lathes and mills, and John had the others. And Jeff purchased this equipment, and this is the equipment we use to make different prototypes and some of the MWO stuff. But this particular jet, I don't know what the size but anyway, about this size. Once you stand next to it, and for a size reference, and
I mean, it's really nice. There's no run out on the chuck. There's no significant run out on it. The Harbor Freight one, you can see whenever I stick something in there.
Plus, it's smaller, right?
No, it's smaller too.
Okay.
It's really small, so I can't do. There's a lot I can't do.
Yeah. I have a Grizzly 9x19 or something ballpark like that. I can barely fit
my 3-inch rotor in there and face off and grind the 3-inch rotor down just a little bit.
So this is Jet. Jet's a pretty good brand. Grizzly. This is another one. This was mostly used for coil winding, but these are kind of close to the same size. But if anybody has a used lathe that's in good shape about this size that they want to donate, I know that would help to expedite a lot of the projects that Jeremiah is working on. Jeff was kind enough to use this to turn down some rotors to help fit them into some magnets. But that is a 3.5-4 hour drive for Jeremiah to come up here and have that done. Plus it does kind of take up some of the shop time that we need to use on the MWOs and stuff. But anyway, that's the size. If anybody wants to pitch in some money to buy a new or used one, or donate one, get a hold of Jeremiah on ienergysupply.com. The email and phone number are on there, and that's the easiest way to reach him.
Like that.
Okay, and also if anybody for maybe a couple $100, Jeremiah needs a camera to document this stuff, because he's usually doing it by a phone. A decent tripod and a camera, I'd say maybe $250 you get something more than sufficient to do 4K or fake 4K. It's like 3900 something by whatever. It doesn't have to be cinematic 4K, which is true 4000 something. But there'll be a see, besides Patreon, you can support iEnergy Supply, Jeremiah's efforts with Patreon. On the new website, we'll be putting up a PayPal donate link. That way, if you don't want to commit to a monthly recurring donation, which you can through PayPal too, you might as well just do it on Patreon, is that with the PayPal one, you'll be able to enter your own amount that you want to donate, or an amount that might be different.
I actually
from
think
Patreon.
You can do that on Patreon too.
Can do that.
But yeah, if somebody wants to just use PayPal, that'd be great too.
Yeah. So anything you can do to support that, so the lathe and a camera to document the efforts.
The thing about Patreon though is I always get my updates on there basically before anywhere else. Now we will have we'll have updates coming out on our website. They might lag a little bit behind.
Yeah.
But also there's a lot of people that like to communicate with me, and I can't get to everybody. So what I do is Patreon makes it real easy for me to message everybody who's supporting me, and I even have a tier on there where I can personally talk to anybody if they join that tier over the phone and help them with their system or tell them about the system. I use that tier. It's tier 4 on the Patreon, but I talk to everybody on Patreon. If they send me a message, I'll always get back to anyone on Patreon.
Okay. And then also, I've done quite a few like live conference calls with Eric Dollard, old school. A real telephone number you dial into, put in the PIN code, and you're in a conference line, and we do an introduction, and go over whatever we want to talk about, and then open up for questions. And we're going to start doing that again now that the conference videos are pretty much out. We're going to be doing that with Eric Dollard, but there's been some requests for me to have other presenters on there, and so you're up to doing some periodic live phone calls and stuff like that. And we can do ones for general public. We can do ones for people who just watch the presentation, because obviously that's going to answer a lot of questions automatically. So stay tuned for that. We'll get those scheduled out, and it'll be a chance to talk to Jeremiah, and that might be a good opportunity instead of answering one email after another, because I got to do that all the time too, and it's time consuming. plus a lot of the questions that people email me about, it's on my websites.
Yeah.
So, read the
Well,
website.
it really hasn't been that difficult for Patreon.
Yeah.
Maybe it would in the future, but I have had no trouble getting back to patrons.
Yeah.
And just having the patrons, but I would like to do the live calls with you, but just having the patrons there with the monthly income, it takes so much stress off of me, and I can get to work without the stress, and I can get things that we need that come up randomly, like here and there.
So a Patreon, that pays the bills.
That pays all the bills.
That pays the bills, and so it's not just a donation for projects. This supports Jeremiah's.
Yeah, and it makes it. It's probably one of the biggest things that kept me going was Patreon.
Sure. Yeah.
But other than other people have been helping me outside of Patreon. Yeah. But before Patreon, I didn't know how long I could continue doing that before I had to go start a business and start installing carpet or whatever, or doing something to try to raise my own funding.
Right.
So the reason this is happening and the reason this is going so fast, or one of the biggest reasons, is Patreon. And so thank you, patrons.
Okay. Any final words before we wrap it up?
Well, we're just gonna have a lot of exciting updates coming. I mean, we're very ripe. The project is very ripe. It's almost done, and certainly by next conference we'll have the entire system all set up there, working and producing usable power for your home. So that's the.
And it's not theoretical. I mean, he's proven it. Small scale with a little generator and stuff. Yeah. It absolutely works.
Generated electricity. We even ran our campsite for like 2 hours on the same tank of water that we heated up that morning. The tank was only this,
which could be heated by solar.
And it only had this much water in it. Yeah. And it was we only started out like 150 or 160 degrees, and there was only this much water in the tank. Right. At the end of the day, we powered our lights to our campsite with the Tesla turbine. Yeah. Yeah. But we want to show the power enough to power your house, not just like some lights at the campsite.
Right.
Which is totally plausible, especially if we fill that tank all the way full of hot water.
Right.
Yeah.
Okay. So visit ienergysupply.com. That website, it's functional right now. All the links are there. It will be developing. Come back and visit the website often, and there'll be some updates. And also emediapress.com. That's where the catalog of all the 2021 Energy Science Technology Conference videos and all the past videos are on there. There's probably getting close to 200 products by now, ebooks and videos. Most of them are conference presentations, and I'm going to be releasing some physical products here pretty soon. New version of the Bedini Rife machine. There's also the MWO. We now have the PC board antenna version, and there's about 3 products that I'm working on, production-ready prototypes. Those are going to be available to get into people's hands here pretty quick. And we don't know what the schedule is going to look like for next year for the conference, but EnergyScienceConference.com, and you can learn a little bit more about it and kind of look at some of the past schedules to kind of see what that's about. And so as soon as we know what next year's agenda is, we'll let everybody know. So thanks for watching, and keep supporting Jeremiah's work. ienergysupply.com. There's a link to Patreon there, and we'll look forward to next updates.
Yep. Thanks.
Okay.